Okay, so we're going to do the performance task probably the next couple of days. So we need to learn how to set them up and solve a linear programming problem. So is that filled in for you already? No, fill that in. Okay, fill it in. And there's a lot of things out there you can do that you don't even know exist yet. So, all right, we are going to define the variables. So that's the first thing, just like we did when we were doing the word problems. Instead of writing equations, we're going to write inequalities. Okay, so we've done the writing equations part before. We did that last Friday. Then we are going to graph the inequalities. So that's what we did yesterday. Then the new thing today is we're going to find vertices of the shaded region. So the shaded region is going to be pretty obvious. I probably don't need to test my points. I really should, but I probably don't need to because I'm pretty obvious where they're going to be. Then we're going to write a function that needs to be maximized or minimized. So this is kind of the real life thing, okay? Granted, some of the scenarios we're going to see are a little bit silly, but this is really how a company could go in and decide how many items to make to maximize or maximize their profit and minimize their cost, okay? And then we're going to evaluate the function by plugging in the vertices. And then we're going to answer whatever the question is that it is posing, okay? So again, they're not short problems. You're going to have to bear with me, and we're going to get through it, okay? Each little step really isn't that bad, okay? But if we take it little step by little step, okay? So we've got Michael, and he's carving animals out of wood. The floating ducks take 10 hours to carve and 8 hours to paint. He can sell the duck for a profit of $18, okay? An American eagle takes 20 hours to carve and 4 hours to paint, but his profit is $30. The total time per week available for carving is 60 hours, and for painting is 36 hours. How many of each type of animal should he create to have the maximum profit? So there's a lot of numbers and information going on there, okay? The first thing that I would do is we got to assign variables, and I would, unlike the other day when we were assigning any letter we wanted, I would probably stick with X and Y because we do have to graph it, okay? So I'm going to start by saying X equals the ducks and Y equals the eagles, because those were kind of the two variables that were running around in there. So in this case, all right, we know that they're going to carve at least some ducks and some eagles, right? Yeah. So we know that there's going to be, X is going to be greater than or equal to 0, and Y is also going to be greater than or equal to 0. Which, notice, did I give you the entire graph, or all 4 quadrants of the graph? No, I only gave you quadrant 1. So this is pretty much going to be a standard equation every time you see it. We might not graph it because it's just saying it's the X and Y axis. Okay, and it's bigger than the X and Y axis. It's going to force it to be in quadrant 1 because it doesn't make sense to have negative answers on this stuff. Okay, all right, so now let's talk about the hours it takes to carve and paint and how many hours there are total. So let's talk about the duck first. I'm going to highlight. So we've got a duck, and it says 10 hours to carve. Wait a minute, I want to be 10 hours. No, I need to write a carving equation and a painting equation, okay? So 10 hours to carve the duck. The eagle takes 20 hours to carve, and how many hours are there for carving? 60. Okay, so we're going to write an equation about carving, okay? So if you want to label it, this is the carving equation. All right, so I've got 10 times, what's my variable for ducks? X, plus 20 hours to carve the what? The Y, the eagles. And that has to be less than or equal to how many total hours? 60. 60, good. Now we're going to write an equation for painting. So this is going to be my painting equation. Okay, I'm going to highlight with a different highlighter color now so that we can kind of see. All right, so it says that we have 8 hours to paint a duck. An eagle is 4 hours to paint, and we have a total of 36 hours. So we're going to write an equation based on that. So what's the duck? What are we going to write for the duck? 8x. 8x plus, what for the eagle? 4y. 4y less than or equal to what? 36. Okay, the next step said go ahead and graph those things. Okay, so we're going to go ahead and graph them. I'm going to start by solving them first, though. So we got to get it into y equals. So what am I going to do with that 10?
Subtract it.
Good. So less than or equal to negative 10x plus 60. That's an x. I kind of started writing a plus sign and tried to turn it into an x. All right, and then what are we going to do with the 20? Divide it. Good. So we end up with y less than or equal to, let's see, what is the negative 10 over 20 reduced to? Negative 1/2 x. 60 divided by 20 is what? 3. Good. Okay. So I'm going to go ahead and graph that. And I know the graph ends up being really tiny down here. We give you a way bigger graph patch than what you needed. So I'm going to go up 3 for my y-intercept. And what are we going to count for our slope?
Down 1 over 2.
Yep, and I'm going to keep doing that because, especially because I'm trying to find vertices that cross. I'm going to keep doing that all the way down. Did you notice that they're all solid? Yeah, so we're going to have all solids. And again, I'm not going to be super worried about testing my point. Okay, it should be obvious where there's going to be a polygon that gets created, and that's the vertices we're going to use. Okay. All right, I'm going to pick another color to write the next part in. So I'm going to get my y by itself again. What am I going to do to move the 8x? Subtract it. So subtract 8x plus 36. And then what are we going to do with the 4? Divide it. So what's negative 8 divided by 4? Negative 2x, and then 36 divided by 4. 9. All right, so now we're going to graph that. So we've got 3, 4, 5, 6, 7, 8, 9. Make sure I did it on 9, because 3, yeah, I look like I'm on 9. You have to be precise on these. Okay, just like when we were solving the systems by graphing, you have to be very precise. All right, what's my slope this time? Down 2 over 1, down 2 over 1, down 2 over 1. I'm going to keep doing that. Notice, ooh, I crossed right there, right? So that vertex is going to be important. All right, if I did my test points, do you see the region that was created in here?
Yeah.
That region is what we would be looking at. Okay. Did I hit right on? Down 2 over 1. It looks like half. Did I do a half? What did we do before? I'm making sure oh yeah. Okay. All right, so the next thing I'm going to do is, let's go back and read what we've got to do, okay? So let's see where we're at. We defined our variables. We wrote inequalities. We graphed. What have we not done? Find the vertices. So the next thing I'm supposed to do in step 4 is find the vertices. So I'm going to go through here, and I'm going to read where they cross, okay? And I'm going to go ahead, and I'm going to write those vertices down, okay? So my vertices. All right, so what's this first vertice right here? And do you see how the x and the y-axis are part of it? And we said they were part of it, we just didn't graph them, okay? Because they were already graphed for us. All right, what's this vertice right here?
0, 3.
0, 3, good. What about this one right here?
4, 1.
Out 4, up 1. All right, now this last one's a little bit tricky. We know it's a 0, right? It's on the x-axis. I didn't graph it very well. You guys thinking about 4.5 looking at your graph? Look at yours again. See how you graphed it. Hopefully maybe you did a straighter line than I did. You could have used a ruler. I couldn't. Okay? So I hit a little bit too close. I'd probably say it's about 4.50. Okay? All right. Let's look at what we got to do next. So what does the instruction say? Write the function to be maximized or minimized. So we have to write another function. All right? And this is something totally new for us. So, how many of each type of animal should he create to have the maximum profit? So we got to talk about money. Is there some information about money in here? How much profit is the duck?
$18.
So wouldn't I say 18 times x, the duck? Actually, I'm going to write this in a different way. I'm going to write a profit equation, a profit function. So we've got I'm going to write it like this. That's just notation, just like f of x is notation. So I'm saying we're going to write a profit function, and I'm going to plug an x and a y into it. Okay? So my profit function we said is 18 times the ducks plus, how much is he going to make off of an eagle? 30 bucks off of an eagle. So 30 times the y. All right. To figure out what he should do, notice these vertices that we've got? We're going to plug those into this profit equation now. All right. So if I make 0 ducks and 0 eagles, what's my profit going to be?
0.
That makes sense, right? I'm not going to make any money if I don't do anything. All right, let's try. I'm going to put in 0 ducks and 3 eagles. So 18 times 0 plus 30 times 3.
90.
So he's going to, if he just makes 3 eagles and spends all his effort into eagles, he's going to make $90. Okay? All right, let's try. You guys keep your work going down. If you still have room, I'm going to have to move it over because of space. So profit of 4 ducks and 1 eagle. So 18 times 4 plus 30 times 1. 102. Everybody okay with 102? And you guys, at that point, plug it into your calculator, right? If you can't do it in your head, just get a final answer. And that's an 18, not an 8. All right, so he makes 102 if he does that. And then our final one was 4.50, which really doesn't make sense because we can't we can't sell half of a duck, right? But we'll try it out anyways. So 18 times 4.5 plus 3 times 0, what does that make him?
261.
Nope.
That's not true.
What's 18 times 4.5?
Oh, 41.
41? 81. There we go. So he makes $81 there. So what's his best shot at making the most amount of money?
4 ducks, 1 beer.
1 eagle, right? So at the bottom there, okay, you're going to write a sentence. I'm going to write my sentence above my graph because that's the only space I have left. So I would say Michael should make four ducks and 1 eagle for max profit. Probably should write maximum profit, right? But for max profit. Did we answer the question they asked?
Yes.
How many of each type should you have to create the maximum profit? Okay. All right. Let's look at example 2. Mine says B. Yours says 2. Okay. I copied and pasted from a worksheet. All right. We've got Sarah. She is arriving at school late because her alarm didn't go off and therefore has only 40 minutes to complete an Algebra 2 exam. The exam has 2 open-ended questions and 15 multiple-choice questions. Each correct open-ended question is worth 15 points, and each multiple-choice question is worth 2 points. She knows it usually takes her 10 minutes to answer an open-ended question and only 2 minutes to answer a multiple-choice question. Assume that for each question Sarah answers, she receives full credit. Sarah must be a really smart student, huh? How many of each type of question should she answer to receive the maximum points possible? Okay, so let's see what happens. So there's we're going to base it off of question type. So do you see how there's 2 different types of questions? All right, so then what are the 2 different types of questions?
2
Open-ended and multiple choice. Okay, so let's see if we can find all the open-ended information. So it says open-ended question is worth 15 points. Oh, actually, you know what? That's going to be our I'm sorry. That's not our variables. That's going to be our maximi. Oh, no, I'm wrong. Open-ended and multiple choice are our variables. Okay, let's try again. So I'm going to say that x equals the open-ended and y equals the multiple choice. Everybody okay with that? Okay. So let's talk about, this one's a little bit different. Okay. Let's talk about the minutes that she has, because there's a bunch of information about minutes in there. So how many total minutes does she have to take the test? 40 minutes to complete the test. So I know that something is going to be less than or equal to 40. And it's going to be the minutes she spends on open-ended plus the minutes she spends on multiple choice. So how many minutes does an open-ended question take her? 10 minutes for an open-ended. Everybody see that information in there?
Yeah.
So I'm going to do 10x for the open-ended plus, what about the multiple choice? How long does it take her to do a multiple choice question? 2 minutes for a multiple choice, so 2y. Okay. Let's see. The other one that we can look at, the other information we have is we know how many possible questions there are on the test, right? No. How many points they're worth, right? So each open-ended is worth 15. No, it's the number of questions. I don't know why the points are in there. Oh, the points are for the maximum equation. All right, so we know we've got 2 open-ended and 15 multiple choice. So we know she could answer 0 open-ended questions, right? But she could answer a total of how many open-ended questions altogether? 2. So she's going to answer between 0 and 2 open-ended questions. Do you see where I got that inequality? We've seen this compound inequality. Hopefully we saw that in Algebra 1. So it's between 0 and 2. Could I write one like that for the y's as well?
Yes.
She could answer 0 multiple choice, but a total of how many multiple choice? 15. So I can graph those things as well, all right? So we're going to graph this inequality and these inequalities here. Okay? Why did I do that? Because I've got to create a region, right? Just like I did on this last one, we created a region and we needed a couple of equations to do that. So I created one inequality based off of time, and then I created another inequality based off of how many questions there were. Okay, so this one was on the minutes, right? And this was on total questions. Does that make more sense? Help out to label what they're for. Okay, so let's talk about the minutes one first. So let's get that graphed. So I'm going to take and move the 10x over by doing what? Subtracting. So we've got negative 10x plus 40. And then what are we going to do to move the 2? Divide it. So what's negative 10 divided by 2? Negative 5x and 40 divided by 2. 20. That was nice of them. All right, let's see. Do I have 20 spots on there? I might. Because it's easier to graph by ones, but if we have to, we can scale. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do we all agree that that's 20? Did you guys count as well? You should have. All right, and then what am I supposed to count for my slope? Down 5 over 1. All right, so 1, 2, 3, 4, 5. Okay, and I'm going to keep counting that off. You guys could use a ruler. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the last one should land right on the axis. All right, and go ahead and notice it's still solid lines, less than or equal to. All right, let's talk about total questions, okay? So her total open-ended questions are between 0 and 2. We talked yesterday about x equals and y equals, right? What did we say about x equals? What kind of a line do we get? We get a vertical line. So basically, x equals 0 is the y-axis. I'm not going to regraph that. I am going to graph what value, though? 2. So I'm going to graph a vertical line. And again, I would probably be using my ruler for this if I were you. That's probably big enough. Just notice I have a point that crossed right there. Okay. All right. I also, so if x equals is vertical, what is the y equals?
15.
Horizontal. Okay. So again, the 0 horizontal is just going to be the x-axis. The y horizontal, and I got to do one at 15, right? So it should go through, that was up at 20 total, wasn't it? So it should go through right here. So I'm going to highlight the region here. If you want to highlight your region too, you can. Let's switch it back to, no, I don't want green, I want yellow. All right, so right in here, do you see the region right in there? That narrow region right in there. Okay, so we've done the variables, we assigned variables, we wrote inequalities, we graphed the inequalities. What's the next step? What did we do next? We got to read the vertices off the graph. How many vertices are there this time?
4.
5.
There are 5. You see what I just dotted in red? And again, you might want to make those a different color in your graph. Okay? So the good news is that when we're doing this for the performance task, we're going to use Desmos. You have to do the 3 of them by hand for homework tonight, but you're going to use Desmos to get to do the task. So the vertices will pop up really nicely on there. Okay, so let's list our vertices. So what's this first vertex down here? 0, 0. Perfect. All right, what about this vertice right here? 0 what? 15. Good. What's this vertex right here? Careful. Is it out 2? It's out 1, 15, right? Okay. And then this one right here is what?
210.
210. And this one down here is what? 2, 0. All right, there were still some numbers in there that we didn't use, right? Let me go find those numbers that we didn't use. So we had something about how much the questions were worth. It was worth 15 points for an open-ended. Multiple choice is worth 2 points. It wants to know how many type of each question should she answer to receive maximum possible points. So our maximizing equation, okay, is going to be the number of points. So I'm going to do that in orange. All right, so let's write our, last time we called it profit. This time we'll call it a points equation, so the P still works. Okay? That's a really awkward comma, isn't it? Okay, so how many points is her open-ended worth? So 15 times the x plus how many points is the multiple choice worth?
2.
So 2 times the y. And do you see how those 15 and 2 are coming from the points and they're opposite of the other 15 and 2 that were the total number of questions? All right, so now we're going to go ahead and we're going to plug in all these values. So I'm going to give you a minute, just like we did in the last one. I'll do 0, 0. Okay, actually, let's split this up in the room. Okay, so I've got 0, 0 done. I know it's going to be 0 questions. All right, so I want these first 2 rows in the front here. You guys do, on the left side of the room, I want you guys to do 0, 15. The 2 rows on the other side, you guys are going to do 1, 15. So that way we're splitting the work here, right? All right, these 2 rows here, you guys do 2, 10. Okay, and then you guys here, back here, do 2, 0. Okay, 2, 10, and then the last ones are going to do 2, 0. So everybody's calculating their one maximizing equation. All right, give you about another 10 seconds to do your calculation. Okay. what? For what? The equation I gave you? Okay. All right. First two rows on the left. 0, 15. What'd you get? 30. Okay. All right. Two rows on the right. What did you guys get for 115? 45. Do we all agree with that in those two rows? All right. What about 210? 50. Do we all agree with Ivan up back here? Okay. And then 20. What did we get?
30.
30?
Yep.
All right. So, what's her best case scenario? What should she answer?
210.
Which one gives her the most points?
Opening the two-ended and 10 multiple choice.
So she should answer both open-ended and 10 multiple choice questions, and that will get her the highest score on the test. Okay, so let's write that in there. I'm going to make myself some white space here so I can write the sentence with you. Or some kind of space. Okay. All right, I'm going to write on that blue square. Check this out. I almost never get to use white. There we go. All right, so Sarah, right, should answer two open-ended and 10 multiple choice to maximize her points. So to maximize points. All right. Once you've done writing that sentence, I need you guys to open up haiku. Okay.